Jai Hind students, welcome to my YouTube channel. I'm sure students you must be studying real hard, you must be putting in your sincere and dedicated effort. But students, I must mention one thing over here. While studying, do try to enjoy your studies. Please don't take any stress while studying. And it is feasible only when you study, you enjoy your studies, only when you are able to understand the concepts. It is only when your concepts are clear that it will create interest in that particular subject. So students, at any cost, avoid rote learning, avoid cramming. Try to understand the concept. And I'm very sure everything will become very simple for you. Right? So students, do enjoy your studies. Right? Well, with that, in the previous session also we have discussed some very basic numericals based on electricity, and I'm here again with these numericals and some conceptual questions based on electricity only, right? So during this session we'll be discussing these questions. So students, let's start with the first one. First question is a numerical, and it's given that we are supposed to compare the power used in 2 ohm resistor in each of the following circuits. First circuit is a 6 volt battery in series with 1 ohm and 2 ohm resistors. This is 1 ohm, this is 2 ohm, they are connected in series, and a battery of 6 volt. Here we are supposed to find out the power. Suppose it is P1, right? And in the second case, a 4 volt battery in parallel with 12 ohm and 2 ohm. That we'll discuss later. Let's consider the first part. Let's find out the power. Power, students, you are aware, it has got 3 formulas, right? Each one can be derived from the other. P equals to VI, these are the formulas. P is equal to VI, P is equal to I square R, P is equal to V square by R. Right? These are the 3 formulas. So here what we do is, current across both the resistors is constant as both the resistors are connected in series. So what will be the current, students? Current would be the net current. I am talking about the net current. Net current, as per the Ohm's law, it would be potential difference over net resistance. So V by R. So net current flowing would be, net potential difference would be 6, and net resistance of the circuit, these are connected in series, so 2 plus 1. So net resistance in the series would be 3 ohm. So current is 2 ampere. Therefore, current across each of these 2 resistors is 2 ampere as they are connected in series. So the rate of heat produced, or the power across the 2 ohm resistor, it would be equal to I square multiplied by R. R is 2 ohm. So that would be 2 square, current is 2 ampere into 2. That would be equal to 8 watt. Am I clear, students? Okay, now let's consider on the second part. A 4 volt battery in parallel with 12 ohm and 2 ohm, right? It's like this. This is 12 ohm, this is 2 ohm, and this is a battery of 4 volt. This is 4 volt. Now look, students, in the parallel connection, the potential difference across each of the resistors connected in parallel is constant. So, potential difference across each of these 2 resistors is 4 volt. Here also it's 4 volt. Now look, P2 is to be found. That is the rate of heat produced across the 2 ohm resistor. That is the power across the 2 ohm resistor is to be determined. Now V is known across the 2 ohm resistor and the resistance value is 2 ohm. So we have to make use of this particular formula. It can give us the result directly, right? So it is V square divided by R. So V, what is the potential difference across the 2 ohm resistor? It's 4 volt. So 4 square divided by resistance. Resistance is 2 ohm. So it would be equal to 16 by 2. That is 8 watt. Am I clear, students? So we need to compare. So the ratio of the power output across the two ohm resistor in both the cases is same. That is, ratio would be 1:1. Therefore, P1 divided by P2, it would be equal to 1. Each being equal to 8 watt. So, this is the solution of the first question. Right, students? Okay. Let's consider the second question. It's a very basic question. Two electric devices are given and we are supposed to find which of the two uses more energy. A 250 watt TV set for 1 hour or a 1200 watt toaster when used for 10 minutes. We are supposed to find out the energy and we are supposed to state which of these two uses more energy. So second is energy is to be determined. Now students, we are aware power is the rate of doing work, right? Or the rate at which the electrical energy is consumed. So power is energy over time. Therefore energy would be equal to power multiplied by time. So let's consider the first case. In the case of 250 watt TV. So energy E1. Power of the TV is given to be 250 watt. Time it's given to be 1 hour. So what you get is 250 watt hour. Okay students, let's convert it in kilowatt hour. So what we do is, it can be written as 250 divided by 1000 kilowatt hour. So that will give us 1/4 kilowatt hour. That is 0.25 units. As we are aware, kilowatt hour, it is the commercial unit of electrical energy. It is also known as BOT, B-O-T, Board of Trade Unit. 1 unit means 1 kilowatt hour. And 1 kilowatt hour in SI is 3.6 into 10⁶ joules. So this is in kilowatt hour. The electricity bill comes in this unit, right? 1 unit stands for 1 kilowatt hour. So 0.25 units of electrical energy is consumed if the TV set is used for 1 hour. Now let's consider the second case. The case of a toaster. Its power is given to be 1200 watt and it is used for 10 minutes. So it has to be converted to hour. So 10 minutes is 10/60 hour. So that will give us 1200 into 10 divided by 1000 into 60 kilowatt hour. I have converted in kilowatt hour, dividing it by 1000, isn't it? So what I get is, so 1/5, 12 5 is 60, so 1/5 kilowatt hour or 0.2 units. So obviously, toaster when used for 10 minutes, it uses 0.2 units of electrical energy. So definitely, the television when used for 1 hour will consume more electrical energy. Right students? And again I must mention, kilowatt hour is the commercial unit of electrical energy. And we have discussed earlier, 1 kilowatt hour is equal to 3.6 into 10⁶ joule. So this is the relationship between the commercial unit of electrical energy and the SI unit of energy. Right students? Okay, so we are done with question number 2 as well. Let's concentrate on question number 3. Question number 3 is, when a 12 volt battery is connected across an unknown resistor, there's a current of 2.5 milliampere. This is milliampere. 1 milliampere is 10⁻³ ampere. Find the value of resistance of the resistor. Okay. This is the unknown resistance. Suppose it's given by R, right? So 12 volt battery is connected across it and a current of 2.5 milliampere flows through it. So V is given, I is given, R is to be determined. What is the relationship connecting these three physical quantities? Yes, it is V equals to IR as per the Ohm's law. So as V is equal to IR, therefore R would be equal to V by I. Now converted in SI. So in that case we will get the value of resistance in Ohm. So potential difference is 12. Current is 2.5 milliampere. This is 2.5 milliampere is 10 to the minus 3. Right? So don't forget to convert milliampere into amperes. So what we get is 12 divided by 2.5 into 10 raised to the power 3. It can also be written in this manner: 120 divided by 25 into 10 raised to the power 3. Am I clear, friends? So that will give you 24 divided by 5 into 10 raised to the power 3, or 4.8 into 10 raised to the power 3 ohm. So this is the value of resistance. So this is a quite simple question based on Ohm's law. Directly use formula V equals to IR. So out of these three physical quantities, if two are known, then the third one can be easily found. Right? So we are over with question number 3 as well. Now question number 4, students. A copper wire is given and its diameter is given to be 0.5 millimeter and resistivity is also given. So let's write down the given information. Diameter is given to be 0.5 millimeter. First and foremost, convert the values in SI system. So 0.5 millimeter, it would be 0.5 into 10 raised to the minus 3 meter. Clear, students? Or it may be written as 5 by 10 or 5 into 10 raised to the minus 4 meter. Clear? This is the diameter, right? Okay. Next given is resistivity. It is also known as specific resistance. It is given to be 1.6 into 10 raised to the minus 8 ohm meter. It's already given in SI. What will be the length of this wire? Length of the wire is to be determined, and resistance of this wire is 10 ohm. So students, first try to recollect the formula connecting R, rho, L and D. D is the diameter. So what's the formula? The resistance of a wire is given by rho L by A. A is the cross-sectional area. This is the wire. So this is the cross-sectional area. This is the cross-sectional area. If its radius is R, then area, it would be equal to pi R square. And we are aware relationship between radius and diameter is R is equal to D by 2, isn't it? So pi, it will be D by 2 whole square. So it will be pi D square by 4. This is the cross-sectional area. Right, friends? So let's substitute this value over here. So area is pi D square by 4. Therefore, R will be equal to rho L divided by A. A is pi D square by 4. Right, students? Here, what we are supposed to do is we are supposed to find out the length of the copper wire. So as to make the resistance of that wire 10 ohm. Right? So L, it is equal to R into pi into D square divided by 4 into rho. So students, first prepare or form this formula, and in the last step try to substitute the given values. That should be the approach while solving a numerical, right? So what is the value of R? It's given to be 10. Value of pi is 3.14, or it can be written as 22 by 7. What is D? D is 5 into 10 raised to minus 4. So D square, it will become 25 into 10 raised to minus 8. It's D square. So 5 into 10 raised to minus 4 whole square. So it will be 25 into 10 raised to minus 8 divided by 4 into rho. Rho is given to be 1.6 into 10 raised to minus 8. So I hope you can easily solve it. 10 raised to minus 8, 10 raised to minus 8 get cancelled, isn't it? This will be 5, this is 2. This again can be written as, so let me solve it over here. So what you get is, actually these are the calculations which you should be easily able to do it. But anyway, let me solve it for you. So L, it will be equal to, what is left is 5 into 3.14 into 25 divided by 2 into 1.6. Clear, students? So, what we get is 5 into 3.14 into 25 divided by 3.2. Clear, students? Now look, approximately I will give you the answer. Now 3.14 divided by 3.2, it will be somewhat about 0.9, something like that. 25, 5 125. So 125 multiplied by 0.93. So it will be roughly about 122 or 123 meters. So if you solve it, it will be about 122.7 meters. Right? You can solve it yourself. Clear, students? Okay, so we are done with question number 4 as well. This question again was based on direct formula relating to resistance. R is equal to rho L by A. A is the cross-sectional area of the conductor, which is pi r square. R is half of the diameter, so cross-section area becomes pi d square by 4. That's the formula to be used, right? Okay. Next question, 5th one. Very, very important one, both from practical point of view as well as from your theoretical examination point of view. 5th one, students, it's very, very important one. Why ammeter is always connected in series while voltmeter is connected in parallel in an electrical network? Right? Now ammeter. Now remember some basic points about ammeter. Ammeter is a device. It is an electric device. It is a measuring device which is used to measure electric current flowing through a circuit. It measures electric current. It measures current. Right? Second, this is the first point. Second, an ammeter is an extremely low resistance device. The resistance of an ideal, perfect ammeter is 0. So, it is an extremely low resistance device. It is an extremely low resistance device. Now look, in series we are aware current always is constant. Now students, whenever some measuring device is to be connected in a circuit, then on introducing that circuit element, the current flowing through the main circuit shouldn't get altered. It shouldn't get changed. Isn't it? So whenever, whether you are connecting a voltmeter or you are connecting an ammeter in an electrical network, it should be connected in such a manner so that the main current flowing in the circuit remains constant. So if the main current remains unaltered, then the device will be able to measure the current accurately. Also, the device which is voltmeter, it can be used to measure potential difference, because if current remains unchanged, then V equals to IR, that is the potential difference across any section of the conductor, that will also remain unchanged, and hence the true value can be determined. So again I repeat, students, whether you are considering ammeter or a voltmeter, these are measuring devices, right? They are to be connected in an electrical network in such a manner so that on their introduction in the electrical circuit, the current through the main circuit shouldn't get changed, it shouldn't get altered. It is only then that ammeter can measure the true value of current flowing through the circuit. It is only then that a voltmeter can measure the true value of potential difference across any section of a conductor. Right? So what I mean to say is that this is the main circuit, this is the main line. And suppose current I is flowing, right? And this is a conductor. Obviously, it will offer some sort of resistance. Suppose the resistance offered is R. Suppose the resistance offered is R. So, ammeter, while connecting in a circuit so as to measure current, it is always connected in series, right? So, ammeter is to be connected like this. This is a symbol of an ammeter. It is always connected in series. Now, its resistance is suppose RA. RA is the resistance of the ammeter, which is very, very small. So on its introduction, on the introduction of ammeter, when it is connected in series, what happens is net resistance of the circuit, since they are connected in series, it will become R plus RA. Since resistance of the ammeter is extremely low. It is almost negligible. So therefore, net resistance of this circuit, even on the introduction of this ammeter, remains same. R plus RA. RA is negligible, so it will remain the same. So, on connecting the ammeter in series to an electrical network, the resistance of the network remains constant. So, which implies that current will remain constant. Current will remain unaltered, and it is this current which it will measure. So, this is how the ammeter is able to give us the actual value of the current flowing through the circuit. Clear, students? So this is the very reason why ammeter is always connected in series. I hope you have understood the concept. Right? Now the second part, students, regarding voltmeter. Volt, it's the SI unit of potential difference. Meter, to measure something. It's a device which is used to measure something. So voltmeter is an electric device which is used to measure the potential difference across any 2 points or across the 2 ends of a conductor, right? And voltmeter, while connecting in a circuit, is to be always connected in parallel, right? So voltmeter, it is used to measure potential difference. It is used to measure potential difference. And you are aware, potential difference across the parallel combination is constant. And second is, students, a voltmeter is an extremely high resistance device. It is an extremely high resistance device. So, the resistance of an ideal, that is perfect voltmeter, is infinity, right? So, it is an extremely high resistance device. It is an extremely high resistance device. So, resistance of a voltmeter, it approaches to infinity. The resistance of an ideal ammeter, it approaches to 0. These are the basic fundamental points which you should be aware of. Ammeter, it's an extremely low resistance device. The resistance of an ideal ammeter is 0. While voltmeter, it is an extremely high resistance device. An ideal voltmeter possesses infinite resistance, right? So, voltmeter, which is used to measure potential difference, is to be always connected in parallel. I'll give you the reason. This is, suppose, the circuit, and current I is flowing. And we need to find out the potential difference across this resistor. Now what happens is, as I've told you, an electric device is to be connected to an electric network in such a way so that on its introduction, the current flowing through the circuit should remain unaltered or unchanged, right? Now what we do is, suppose I connect a voltmeter over here in parallel like this. Now this point will act as a junction. Some current will flow through this branch and some current will flow through this branch. This is the main current flowing through the main line, right? Now as I told you, students, voltmeter is an extremely high resistance device. So its resistance of a voltmeter is approaching to infinity. So obviously, current will tend to follow least resistive path, isn't it? So even if current flowing is 100 ampere through here, so most of the current, almost 100 ampere current will flow through this branch only, and negligible current will be drawn by the voltmeter because of its extremely high resistance. I repeat, students, voltmeter being a very, very high resistance device, when connected in parallel, it will draw negligible current. No current will be drawn. Almost, it will not draw any current from the main circuit. So the same current will flow through the resistor. So even on the introduction of this voltmeter, the current flowing through this resistor will remain same. Isn't it? So now it will be able to give the actual value of the potential difference across the points AB, which is I into R. Clear, students? So this is the very reason why voltmeter is always connected in parallel to an electrical network. Clear? So this was a very, very important question. Next one, question number 6. Why is the series arrangement not used in domestic circuits? This is again a common sense question. This is again an interesting one, and all the students must be aware of this concept. This is also a good question. Why is the series arrangement not used in domestic circuit? In households or in labs, in schools, in industries, we make use of parallel connection. We don't use series combination, right? I'll give you an example. Let's take the case of a household circuit. Generally in household we make use of several electrical items, starting from electric iron, electric fan, electric bulb, electric refrigerator, isn't it? Then AC, then cooler, then water filter and whatnot. Right? Everything it's working is based on electrical energy only. Right? And all these devices have got different rating, but they operate on the same voltage. They require different currents, but they operate on the same voltage. That is 220 volt or between 200 to 240 volts. Right? That's the operational voltage. Now, what happens is, let us assume that these devices are connected in series, like this. This is an electric bulb. This is a heater. This is a fan. And this is any other electric device. Right? There's any other, suppose this is filter, electric filter, and so on. And they are connected in series. The resistance of this bulb is RB, resistance of the heater is RH, resistance of the fan is RF, resistance of the filter is RFL, filter. They all are connected in series. It is equivalent to this. They all are connected in series. This is bulb, this is heater, this is the resistance offered by the fan, and this is the resistance offered by the filter. They are all connected in series, right? And 220 volt is applied over here. Obviously 220 volt AC, 50 hertz, that's the frequency. AC, that's the alternating current, which we'll be discussing in the higher class, right? Okay, coming back. Suppose a constant current is flowing. In series, the current is constant. So same current must be flowing through each of these electrical components, right? But the potential difference across different resistors would be different. Remember, students, all the electrical appliances which we use operate at the same constant voltage. But here, if we connect it in series, then all the devices will derive different potential difference. The current will be same, but they will operate at different voltages. Right? That's the first drawback. And the most important drawback, the essential point. Suppose this bulb gets fused. That is, this bulb stops working. So what happens is, it stops working. The filament either melts or something happens, as a result of which the bulb doesn't glow. Right? So it will act as a circuit breaker. So now what happens is, since this bulb is not glowing, it will act as a circuit breaker. So current in the other circuit elements will not flow through them. Right? So now the current becomes zero in the other circuit element. So out of all these electrical appliances, even if one electric appliance stops working because of some fault, then it will act as a circuit breaker. It won't allow the current to flow through other circuit elements. So as a result, what happens? All the circuit elements, all the other devices will also stop working. And obviously, students, this situation is not at all desirable, isn't it? We would want the other devices to work smoothly. So that cannot happen if the devices are connected in series. So I hope you have understood the concept. And in case these devices are connected in parallel, then what would happen is, this is the parallel combination. So both the drawbacks can easily be overcome. This is suppose bulb, this is suppose the heater, this is suppose the fan, this is suppose the filter. All are connected in parallel. So in parallel the potential difference is constant. So all these electrical devices will operate at the same voltage of 220 volt. Clear, students? But obviously, at this point, different resistances will derive different current. So current flowing across each of the devices would be different depending upon the resistance which it offers. Now, the most crucial point. Suppose the bulb stops working. The bulb stops working. So in that case, this bulb will not glow. So here the current will become zero. Current through the bulb will become zero. So bulb will stop working. But it won't affect the working of the other devices, as the current will keep flowing through these circuits. Suppose this is I1, this is I2, this is I3. So other three electrical devices will keep on working smoothly as usual. So in the parallel combination, the working of one electric device is independent of the working of the other one. Clear, students? Obviously this is the preferable situation. So this is the reason why we always prefer parallel connections. Right? I hope you have understood the concept, students. Okay, let's discuss the seventh question. Why are copper and aluminum wires usually employed for electricity transmission? Now look, students, electricity can be generated by various ways, isn't it? One is hydroelectric power station, the other one nuclear power station, which makes use of nuclear energy and then convert it into electrical energy, right? But the point I'm making is, the electrical energy so produced in power stations have to be transferred to distant places, to distant locations, and that is done through connecting wires, which are often made of either copper or aluminum. Why copper and aluminum are used? Now what happens is, during the transmission of electrical energy, these materials offer some sort of resistance. And students, we are aware, whenever a current is made to pass through a conductor, what happens? The conductor gets heated up. So some electrical energy is wasted in the form of heat energy. That's heating effects of current, isn't it? So ideally, we would want minimum wastage of electrical energy in the form of heat. And that is possible only when we make use of some good conductors offering low resistance. If the substances which we are using to transmit electric current have low resistivity or low resistance, then small amount of heat will be produced, and accordingly small amount of electrical energy will get wasted in the form of heat. So that is the reason why copper and aluminum wires are usually employed for electricity transmission, so as to reduce the electrical energy loss due to the production of heat. Clear, students? So we have discussed all the 7 questions. I hope you have enjoyed this session and hope you have gained sufficient knowledge about electricity. So please do all these questions. Try to utilize the theoretical concepts, right, which we have discussed, and then apply those things in solving numericals and conceptual questions. And students, whenever you have got any doubt, you can always text me, right? I will be definitely responding and clearing your doubts. Okay, students, that's it for this session. Thank you for watching my videos, and keep watching, and do join me in my next lecture. Thank you.